This is the screencast for section 6.1, example 7. We're going to look at some applications of vectors. Well, velocity of a moving object is a vector because velocity has both magnitude and direction. As a matter of fact, in calculus, one of the first applications of velocity you'll see is that positive velocity moves forward or right, depending on, or up maybe, and then negative velocity moves backwards or left or down, depending on the situation. Now speed, the relationship to speed and velocity is speed is the absolute value of velocity, and in the terms of vectors, it's also defined as being the magnitude of velocity, which again, we use absolute value to symbolize. Example 7 asks us to write velocity as a vector. A DC-10 jet aircraft is flying on a bearing of 65 degrees, remember that is clockwise from north, at 500 miles per hour. That's a speed. Find the component form of the velocity of the airplane. So the velocity vector of this airplane is going to be the magnitude of the vector times the cosine of theta, comma the magnitude of the vector times the sine of theta. We can look at the magnitude of this velocity as being 500 because we're talking about how fast it is moving in 1 hour. So the length of this vector would be 500 in 1 hour. And we'll multiply by the cosine of 25 degrees because theta is the angle from the positive x-axis, comma 500 times the sine of 25 degrees. And when I put those values in my calculator, I get that the vector velocity is 453.15, comma 211.31. So the airplane is traveling 500 miles per hour in this direction, straight along its vector. In vector form, what that means is every hour the airplane is traveling 453.15 miles east, straight east, and 211.31 miles, in this case, straight north. Now, if the plane was traveling into a different quadrant, we might be talking about the planes traveling west or south, depending on whether the x-coordinate or y-coordinates are negative. The now try problem number 41 says that an airplane is flying on a bearing of 335 degrees at 530 miles per hour. Find the component form of the velocity of the airplane. So the first thing I'm going to do is draw a picture of the airplane's path. And as you can see, the plane is flying into quadrant 2, so we're going to have a negative x value and a positive y value at the end, hopefully. So this vector has a magnitude of 530 because in 1 hour, the plane will travel 530 miles, and we'll multiply by the cosine of theta. Remember, theta is the angle off of the positive x-axis, so that is going to be 90 plus the difference between 360 and 335. The angle didn't get all the way around back to north, it was about 25 degrees short, meaning our theta is 115 degrees. And then when I plug those values into my calculator, I get the vector negative 223.99, comma 480.34, which means that the plane every hour is flying 223.99 miles west, because that is a negative value, and then 480.34 miles north.